Hello, welcome. I'm Bill Wake. We're here this week working on a regular expression compiler or a matcher generator, and we've got a lot of things in place, but today we're going to work on computing this trigger function and generating some code. I hope we wrap up the code generation today. I think I might do an extra session tomorrow afternoon, just kind of explore some other ways to generate the code and um, maybe some refactoring. We've got some work to do there. Okay, so we're working off an article, Sequential Circuits from Regular Expressions Revisited by Doğan Ulus, and the link is there if you want to get a copy and read along at some point. I've tried to summarize and hopefully made some things make sense. All right, but our goal is we're writing something that takes a matcher generator. It takes in regular expressions and it outputs code. Our code will be Swift code. He generated C++, but we'll keep working on Swift today. Okay. So far we've basically parsed the regular expressions. We've computed skip functions and out functions, and we're working on the trigger, the code generation, and the bit. I have an idea of maybe generating bit flags instead, and refactoring. Like I said, the latter two will probably be in an extra session tomorrow. Okay, so here's where I'm going to try to make sense of what's going on. So you put in a string A, B, or B star B, A, a regular expression of some sort. Then you go through and you mark the positions. So you put basically a 0 at the front and a number representing which letter this is. Okay, we're ignoring the operators and parentheses and all that. We're just putting a letter associated right after we're putting a number after each letter. Okay, so our goal is to generate this table on the bottom, and it basically says you should move to position X if you see this letter and you're already in one of these positions. Okay, and so I think the place that maybe will mentally help the most, at least it did for me, consider position 3. So there's a caret there, but we've either gone A, B, or a B. Okay, and now if you see a B, I'm looking at the first one of those shaded lines, and you're in position 0, 2, or 3. So you're either at the start, you finish the first branch, or you finish the second branch. Then what should you do? You should move to state 3. So you're basically saying I'm going from 3 to 3 because I'm repeating, I'm consuming that B. And then look at the next line. If you see a B in position 0, 2, or 3, same positions. Another thing you can do is move to position 4. Okay, so you consume the B4 there. And this is kind of the essence of what's going on, that we're basically saying I could be in multiple positions at the same time. So I might either, if I were at this point where the caret is, and made this move, I could either be in position 3 or position 4. And it makes sense. You've read a B and you don't know which one you're going to be, because you don't know if you're going to need an A after that. So if you got a B and you got an A in the end of the string at that point, you'd be saying, okay, I'm done with the expression, but you might also be going back for more. So this table basically lets you give a way to keep track of those states that you're in. So on the right, and in the code we're generating, the core is that for loop for char letter of word, and then we have state and next state. So we're basically starting with an initial state up just past the main line, and 1 0 0 0 0 0 whatever. And if I look at these instances, or these rows here, the shaded ones, I'm saying next state of 3. Could I go to state 3? Yes, if the letter is B and the state is already 0, 2, or 3. So that's the first line of those orange lines. And then the next line is, could I go to state 4? Yes, if same conditions. Okay, so it's just a very direct encoding of this table. So hopefully we can make some good progress on this today. I don't see why not. All right, so yeah, this I'd love to have you as a follower. There's a follow button on there if you're on Twitch at all. I normally broadcast 1 to 3 p.m. Eastern time Tuesday and Thursday, and then in the morning 9 to 11:30 a.m. on Wednesday. Okay, so follow that. Or if you are more interested in essays or blog posts, xp123.com is my main site, and there's an update tag there where you can sign up to either get the weekly articles or the monthly ones. The weekly ones tend to be programming oriented. The monthly ones, once a month, I put one that's a little more either general agile or user stories or something a little more broadly appealing, I guess, in our limited domain. Okay, so where we're going to now is we're going to compute this trigger function. That's basically the table we've been looking at. And so the table, it's a set, meaning there's a lot of these things. We had 5 or 6 in the table just now, and it's an integer, an index, move to position I if character equals any of these in the set. And we'll just work our way through just like we did with the other functions, and compute this set. Once we have the set, it's exactly what you need for code generation, and we will generate code. Okay, and yeah, the algorithm we'll get back to later. All right, so let's go to Xcode. So right at the end, yesterday, we put something in. Yeah, basically we put a trigger row class in. So it's got a position, character, and then a set of positions. And we just let you initialize that. The challenge is, like, I started using it, just throwing it in, and people aren't happy. So one thing we know is if we're going to make a set of trigger rows, which is this total structure, we need to conform to hashable. All right, so we want to make a set here. We got to be able to hash this thing. And down here, I think I just threw in something to make it compile, and it didn't make it compile. So there you have it. All right, so let's get compiler tests over on the right. Let's see. I guess that's one too many, but that worked okay enough. All right. So we've got some minor tests. We're not really doing much, and I don't know. Maybe this is more about intermediate code. I don't know, but we're gonna get this thing tested a little bit. So public class trigger row tests extends xc test case. Okay, and I guess we need to be hashable, and hopefully it will just do that for me. Yes. Okay. Okay, so we're saying, are you equal? Well, yes, I think that we can. I think that's automatic enough. We can forego a test on that particular piece. All right, so we got a left-hand side and a right side. So return LHS dot moves to equals RHS dot moves to, and character and I hope sets are comparable like this. LHS dot positions. Okay. Well, I thought it offered to do that. Oh, let's see what else you have to do. I think I have a window around here somewhere. No, let me go get one. I mean, I guess we have a hash function to define, but it's surprising it didn't set it up for me, I guess. Yeah, hash into hasher. Default implementation provided. Apparently it didn't like the default. Okay. Sorry, it's just hasher dot combine. Okay. Character. And positions. Okay. That should make something happy. Okay, and then this thing triggers is a set of trigger row. I don't know if it'll like that or not. Okay. Now, expected expression in container literal. I don't know, can I do this? I don't know what that means. Yep, sorry. My table slid down a little. Okay, unexpectedly. I don't know. That's a weird message for... UI color. I don't know. Unless I bumped something weird. Somebody saying there's weird stuff at the end of a line. Set of trigger row. Nothing. Okay. Build. Oh, darn. Expected expression in container literal. I don't. I've got something weird going on. I bumped something. Okay. We haven't accomplished anything. We've just declared this trigger row at this point. And I don't know, maybe we won't even need a test for this if it's really no more complicated than that. All right, but at any rate, we want to go to our function. Oh, let's see if I've, we need to calculate that trigger function. All right, and I don't know, generate intermediate code maybe isn't the best thing, but all right, what are we doing? We're going to generate intermediate code from the parse and the suitcase. Okay, that does make sense. Let's make this intermediate code tests. Okay. So one thing would be checking these this trigger function. Okay, so I should be able to say, let's see, a literal node. I call it letter match, I guess. Letter match generates basic trigger set triggers. Okay. So we're going to create. I guess if we call parse. Let's see. So we'll let parse, and we'll ignore any errors. Equal parser of something. Well, it's just a literal dot analyze. Okay, so that's going to go to our intermediate. I guess it's all in compiler still. Okay, so we got a compiler and the parse. I don't know, maybe tree is more understandable there. It's our parse tree. We're saying if you do this and you call tree dot, let's say result equals tree dot trigger and the trigger. Okay, we not the node. We give it a starting point. Let's go back to the yeah, so we're passing in a starting point h, which is a set of positions. Okay, and we'll just give it a position. I guess it's kind of arbitrary. Okay, so if I ask you to parse at 3, will that work? Okay, and then this is really triggers. I guess I can call it that. Okay, so a little setup, arrange, act, assert, right? So we create a compiler, we create a, we parse a string, and we tree has no member trigger at this point. Yes. Oh, this I probably just need to put brackets in. Okay, and then what we expect to get back. The situation we had was if you call trigger on a node, a leaf node, it just gets a setback with these 3 values in it. Okay, so IAH. So we expect to get back a set necessary equal, and the first test is always the worst. It's going to be a trigger. Let's do trigger. Okay, if I give this is I, in this case is 1 because it's the first letter, the only letter. Okay, so I expect a trigger with 1. Let's see. Will it? No. Trigger row. It needs these values. Moves to state 1 with character A and the set is the same as what we got passed in. Okay, And I'm just going to format things to make it a little more clear. Okay, and that's what we expect triggers dot first to be. Okay, so triggers coming back as a set. Can't find trigger row. I think that'll catch up eventually. Okay, it's a set, so I think it should have it'll have the first method, but we'll also just assert that there's one row in the set. Okay, so type tree has no member trigger. Yeah, we're going to write that. We're making sure the set that comes back should have one row, and that row should be this. Okay, I, the index, 1, A, the letter, and then H is the set. Okay. We need to add this tree method. Let's add, it's in parser, right? Okay, so what we're saying is a tree really needs a method that does this. So trigger the trigger function, you give it a set of int positions, set of int, and you return a set of trigger row. Okay, and I'm just going to return an empty set for now. I don't know if it'll let me do it that way. Let's try and run it. Should fail. Oh, I wanted that up on the main tree. Sorry. Value type tree has no member trigger. Parser. Let's see. Hello, Artist Minute. So we're doing a regular expression compiler. We've got the parsing in place. We've got a couple functions to compute, and then we're going to generate some Swift code that recognizes that expression. So we're working on this trigger function right now. So we got a node, a sub I, give it a set. We produce this set back, and we're trying to make sure that's what really happens. Okay, but I'm clearly confused on something. So parser, let's see what our parser says. The analyze method, what does it give us back? Here's parser, and analyze gives us the parse, which is the tree, and it gives us a list of errors. Okay, value of type tree has no member trigger. Oh yeah, that's because I messed up where I put that. Okay, so in the parser, let's put this up at the top level tree. Okay, and this is just a sort of dummy return right now. All right, let's see if that builds. Yeah, it's been fun. I think we got a couple sessions earlier this week, and I think today we'll get the code generated, and I might do a little extra session tomorrow. Missing label positions. Okay. Some cleanup. Okay. Can I convert? Oh, I left off .count. Cannot call value of non-function type trigger row optional. And missing label positions. Okay, yeah, that's fine. Triggers. I don't know why it says that's optional. Set of trigger row. Cannot call value of non-function type trigger row? Question mark. I don't know. I don't think I'm getting something here. Okay, I'm going to pull it out and let's let the row equal triggers dot first. Oh, no parentheses. Okay. Trying to get it to fail is always a good challenge. Alright, I don't need compiler, that's fine. But let's see the test. Okay, test blows up. Unexpectedly found nil. So we're getting back, since we got an empty set and we say first, it blows up. Alright, and that's okay. It's kind of what we expected. Okay, so we need to go to our letter match tree, and we're gonna override this function down here. Okay, and we're returning a well, I guess we're returning a set consisting of a new trigger row. I is the position. Character is the value. Yeah, put those in for me, please. Moves to position. Character is value. We may have a type mismatch going on here. And positions, okay, is a set of integers. Well, the set of integers we want is just the positions that came in. Okay, move to position, character value. I'm just going to let this become string in the trigger class for now. Or no, do I need to? Maybe I just need it in the letter match. Let's see what breaks if I make this character. Value. Sorry. At this rate, I'm getting stuck too much. Method does not override method from superclass. Well, that had been there. Oh, superclass. Oh. Let me undo. We'll take the position. My value was value. We're guaranteed there's one in there, so I think we'll be okay with this. be good. Whoops, run. Ah. Something's still unhappy. Oh, I don't want to get into that. Let's just do my value dot first. Okay. Cool. a little slower than I like. This should be no problem because we only create this thing when there's a single character. So I'm not too worried there. But basically, we're just going to get the rest of these functions in. All right. So another one to do. Let's work our way up these. Okay. The question mark is 0 or 1. That should be pretty easy. Okay. And I don't know, maybe this is all right. So test 0 or 1 generates triggers from child. All right, so this case, it's we'll just mix it up slightly, be optional. Okay. I'm hesitant. Let's use 0 here. And it should have one thing in its row, one thing there. The position 1 for B and the set 0. Okay, so if you got B optional and you see a B and you're starting out in 0, then you move to 1, which is after the B. Okay, good. Okay, we'll take this up to 0 or 1 tree. And the rule was you just return the child's set. Okay, so 0, 1 tree, these all have one child. They're unary operators. Okay, and it's even optional to say return on these. So I'll just say child dot trigger with positions of positions. Okay. Good. All right. Can I generalize this? I'm thinking I may need a helper. A little helper function here, make the test a little more understandable, because we're just kind of going through these combinations. So let's make assert trigger assert correct triggers. Okay, and I want it to basically be this. It should take in a string. Text of type string, and it should take in expected of type set of trigger row. Okay, and so I'll take the body of this. This A should be the text. I'm maybe going to remove this assertion. Well, should I? Yeah, so I'll pass in the set, and you will use set equality. So we won't need the count because that's part of set equality. All right, and then this is expected. And then we'll drop the first off, triggers. Okay. And I should be able to call that thing text is A. Our expected is a set of this. Set of one element. Set of three there. If I counted right. We don't have parameterized tests, unfortunately, in Xcode tests, so it makes life a little uglier. Expected, am I missing a parent, or I got one in the wrong place? Set of three bracket trigger row bracket set. Okay. I still messed it up. Okay, it definitely needs to end bracket parent. Here's a left parent for this, and then the right parent that ends the moves. Set of three. And then one more parenthesis for the assertion, right? You happy? Okay. All right. That bell was time for a break. So we'll just take a 2-minute break, come back and pick up from here. See you in a bit. All right, welcome back. Let's get this next test in the same format. So assert correct triggers. The text string is B question mark. The expected is basically this, except that's a B. Okay, parameter 2, yep. And then I don't need this. Spacing could be better. Okay, and let's run these. I don't know, that name could be better maybe. Assert correct triggers. I don't know. Trigger position set of 3. Do we care about this initial set? I mean, the real usage is more like this on a normal case. And that's really mostly providing an initial set. I'm not sure it makes a big deal. Okay, cool. So we've done the first one and the last one. Let's take this one next. Actually, these two were kind of similar, like basically identical. One way would be say like this is the default behavior of a binary operator, but you can override it if you don't want to do that. Let's maybe take that. Okay, so this is test one, zero, or many. Generates triggers, and then we want trigger E with out of E union H. Okay. Assert correct triggers. All right, this one has to be a 0 or more. So the out, we did this function before, is the set of possible final characters of the string that precede it. So if we have a literal like A, then that's the only thing we have to worry about. I don't know who chose this formatting. Okay, let's. Okay, so in this case, you got A star. So the result is we have to take the union. Let's see. Little head. Okay, we're taking the trigger of E, the child's trigger, but passing in another set. Okay, so the child's trigger in this case is A. So we know for A it's really 1A 0. Okay. If we're passing in, let's see, move to 1. A with 0, and I think we want 1, right? Okay, so we're going to take the child's trigger, pass. So the expression is the child, and out of the child is the possible final positions of the child, union with whatever went in. Okay. And I think it will blow up the same way these other ones have blown up. Okay. Some trigger row is not equal to an empty row because we don't override the parent. Okay. So we'll put this in unary operator as a default. Okay. We're going to return child.trigger with, let's see, I don't know. Not sure why this isn't sticking in my head. We're going to take the trigger of the child and take the out of the child union with what came in. Okay, so the child.out union with positions. Okay. Missing argument positions. Yes. Okay. And I think that passes. Okay. And then the one or more, one or many, is the plus. Okay. And it's the same formula, so it's the same expected result. And actually this is more, confirmatory because, oh man, yeah, that can't fail. Okay. This is confirming that we really do have the sort of default implementation right. I don't know. Maybe it's maybe I'd be better off putting it in both. Okay. And still working, I hope. All right. Now, I guess we'll do alternation first, because okay. So we have A or B. I mean, any possible thing like that. We're expecting the union of the two. Okay, so let's take, yeah, A or B is the trigger of the two with the same set coming in. All right, so A or B. All right, and what we expect back is two things. Trigger row. Is this going to highlight for me? Trigger row, yeah. So that's the one. Okay. And then we want trigger row moves to character positions. Okay. So the A character is 1, and the B character is 2. And this thing is set of 0, 2. Okay, so we're passing in the initial set, unioned, with the two situations. One is A goes to 1, B goes to 2. Either one's an acceptable place to be. And this function is test alternation generates union of child triggers. Okay, should fail. Okay, let's steal this declaration. Okay, so we said this is child left dot trigger of positions union with right dot trigger of positions. Should pass. Oh no. Build succeeded. Did I compute them right? Okay. The set for A by itself is 1A, whatever it is. 1A, whatever it is. Union. Oh, did those sets not union? H. Our H was the set 0. Trigger of E1 with H should just... Oh, I guess it's only the one we got. So, yeah, I did more like... I assumed I should get those, but let's get the answer right first and then fix it up. Okay, if I pass in 0, I'm only getting 0. Okay, Um, and that's actually sensible. If I'm in position 0 at the start of the string and I see an A, I move to 1. I see a B, I move to 2, but nothing moves me back to 1, which is what my answer said. So that's one thing. The other is, it's clear we need a debug description on this thing. And I don't know if, I don't really know how that works. I know there's a method you can give it. I don't know if you just give it or if there's a protocol you have to do. Oh, maybe that's the protocol. Yeah. Debug description. So custom debugs. Well, we'll just take that. And that's in compiler. And I'll just paste that here for a moment, but I want this. So I'm making my test a little more readable if I provide this function. Okay, so my debug description, I'm going to make trigger row. I want to have the moves to position. Oops. Character. And I'll hope positions, I'll hope the set already has a debug description. And we'll make this one wrong again. Trigger 1A 0 does not equal trigger B, or yeah, 2B 0 does not equal 2B 33. Okay, so that's definitely something I can work with. Not beautiful, but it's enough to figure out what the test messages mean. Okay, so back to the parser. We got one last case with multiple cases to it. So let's take concatenation. So we're doing this giant case. So let's take the case where the left child does not skip. Okay. Concatenation where left child cannot be empty. Okay, so concatenation, the left child is A, and that cannot be empty, and we'll do B. All right, so the answer, let's go back, oops, is this lower line, trig E1H union trig E2 with out of E1. Okay, so trig E1H, that's the child. Let's see, so trig E1H, well, that's the A with H is 0, okay. And then the second one, I don't have a good way to get this on my other screen. Trig E1H, okay, union with trig E2 and no H, just out of E1. So out of E1 is position 1. think that's what we're saying. Out of E1 is 1. Okay. So move to position 2 after B if B is there and you were in position 1. I think that's right. Okay, let me peek one more time. All right, so trigger of E1, the child with the original set, unioned with the trigger of E2 and out of E1. Okay, so this will fail. I think there's no danger of getting this one right on the first try. Okay. The assertion 2B1, 1A0 not equal to blank. Okay, empty. All right, we'll take the declaration again. Okay, so this one was trigger of the left child, trigger with the original set, union with the trigger of the right child, in left dot out. And I don't know if this will improve the readability. Okay, so left trigger union with right trigger based on positions of left dot out. All right, let's make sure that's E1 dot out of E1. Okay, and H doesn't go in at all on the right hand side, which is positions. All right, that should pass. Okay. Now this concatenation where the left child can be empty. Okay, so let's take A star B. That's definitely can be empty. Okay, so if the left child can be empty, well, it's the same as before, trig E1H. But instead of out of E1, it's out of E1 union H if skip. Okay. So, oh man. So our E1H, that's just the A0 thing. Then we want the trigger of B which is 2 with out of E1, which is A, 1, position 1, union with H of 0. Okay, so 0, 1. All right. This, I think, goes to 0, 1. Character position 2B. And does this make sense? So A moves to position 1 if you're in 0. Yeah, that's true. If you're in 0 or 1 and you see a B, you move to 2. Okay, so I think the result is the expected values, I think, are right. Okay, and empty, right? Oh no, we get the old answer that doesn't take into account doesn't take into account that we're adding something. Okay, so this case is we got the two cases. Well, let's okay, I'll just write it out this way. So if left dot skip, in other words, if it can skip, oops, else, okay, and we're going to take left dot trigger positions dot union right dot trigger positions, and now it's not just out of E1, it's also dot union H. So it's left dot out dot union with positions. And these are the two returns. Okay. The hard case. Okay, 1A0 matches. Oh, it's 1A10. Left child can be empty. All right, so if skip E1, if the left child can be empty, we got trigger of E1H, which is the star one, union with the trigger with E2 out E2H. Okay, I don't see how the left gets an H in there unless I'm messing something up. What are the odds of that, huh? Okay, left, there's H, positions. I don't know what H even stands for in the paper anyway. If you take the left, trigger positions, that's the trigger of E1 comma H. Okay, and we union it either with left dot out or left dot out union. Oh, is it left dot out or right dot out? Out is left dot out union with H. E1. I mean, basically, we're adding an extra union with H on the right hand side for the skip case. Okay. This is definitely where you all can speak up because it's not obvious to me what's going on. Let me make sure the formatting is right and doesn't reveal any weird mistakes. Okay, if left can be empty, return the left with its trigger positions and union that with the right's triggers based on left dot out, union with the positions going in. Okay, so I don't even see how we can get a trigger 1A0 my debug printing is not as helpful as I wanted here. Let's put an extra paren there just to make things balance out when they do things. But that's clearly not the problem. We'll let it run just to get the better stuff. All right. Yeah, I don't understand 2B10 trigger 1A0. 1A10 is not equal to this ambiguity about expected and actual is nothing I'm a fan of. Okay, so um, 2B10, 2B01, that should be fine. But somehow they got trigger 1, A10. Oh, they are correct. Because it's optional. So A star, let's go to our A star case. It is 0, 1 coming back. So it's that. Okay. So the A star up here we can see returns 1A01. Should return 1A01 down here. And then moves to 2 on either position. Okay. I hate getting this ever making this ever so confusing. Okay. Now this code, let's see if we can. I'm not sure how to improve this, but there's definitely duplication. I mean the only, all right, let's say the right side, the right triggers are if it's left.skip, right trigger positions, if it's left.skip, maybe I want, yeah, right. Well, this would, one way would be left.out.union positions. The other way would be left.out. Okay, that would get this term here would be right trigger positions, and this would be right trigger positions. Okay. This should pass because it's really not any different. Okay, now these two things, they're both identical, so I don't really need this check. Okay. Concatenation. So right trigger positions. If you're skipping the left, you take the union of them. If you're doing that, yeah, I think that's okay. Make sure that's still good. Okay, let's save. So we have calculated the trigger function. Okay, this is the hard part. I can definitely tell you, when I went through the paper and worked through the example and tried to get the trigger functions, it's very easy to get lost in there and mess that up. So, yeah, okay. But that means we're ready to go on. All right, and now we're kind of back to this situation. We're going to take this table in, and we're going to generate this stuff. It's actually the table and a little extra stuff, but we got the algorithm. Okay, this is also confusing. I guess that's the only way to say it. But it tells us what we need. We need the number of letters, the number of letter matches. We need to know the skip for this function. Actually, I don't see that being used. We certainly need to know the out for this function because it's the last position. So at the very end, we say, are you in any of these legal final positions? And if you are, then you return yes. You match. And the trigger. So our intermediate code needs to have these four things in it. Well, I don't know about skip. I don't think I see anything that references skip in here. So at least these three. Okay. Um, the count, the out, and the trigger. All right. So what I want to do, oops. Okay, back to the compiler. This is where, I don't know, the suitcase, okay, the parse has the tree and trigger is on there. So that's that's okay. But the intermediate code, it's got original expression. Whoops. Original expression, this thing code, which we don't need, and triggers, which we do, but it's got to come from our parse. Okay, so triggers is our input. It's our parse tree. And I don't know, I'm gonna make this tree again. I'm happier with the name tree than parse and input and everything else. Okay, the suitcase I don't think has the right stuff. Right now it has the original string, which is good, but we also need the count of this is the count of, well, it's actually considered the size of the expression. Okay, it's the number of things in there, and then we need the out positions is set of int. Okay, that's the stuff the algorithm needs. Okay, count, skip, I'm skipping, out, and the trigger function. Okay. I don't know if this will build or not. You probably have to, the suitcase probably doesn't initialize correctly. Be able to build. Okay. Suitcase, yeah, this really should be coming out of the parser. Okay. All right. So we'll take a couple minute break and we'll come back and we're going to make our parser return the suitcase with the stuff we want in there. Right now it doesn't have these other size and out positions, but the parser does know that information, so it will be relatively easy to make it produce that stuff. Okay. So yeah, let's take that break and join you shortly. All right, welcome back. I probably should have set a timer for myself, but I'm very bad at that, as you probably realize by now. But what I want to do is I want to make analyze, spit out three things now, not just the parse and the errors, but also the suitcase. So let's go to parser and find parse down here. Okay, so parser and then analyze spits out tree and errors. Well, it should spit out suitcase as well. Okay, and let's see. So the position count, it knows that, but let's try and put a junky suitcase in here first. Set. Okay. I don't know if this feels weird to you to have these return values like this, but I think in a way it's a good thing that it's being very explicit. Like, this is what you get from a parse. You get the parse tree, the suitcase, which is sort of additional information, and the errors, any errors that happened. Now I want to make I want to put a test in for this situation. I should get the right stuff out. So let's get a parser test. And I'll just move that over here. Okay. So I want to make sure the analyzer spits out the right stuff. Analyze returns right. Returns valid suitcase. I don't know. So we want to make sure that tree, suitcase, and errors. I'm going to ignore errors. I'm going to ignore tree because we tested that all over the place. Equals parser. And we'll just do a simple phrase dot parse dot analyze. Okay. And then I want to assert equals suitcase no, that's not right. Oh, it's one thing. Okay. Original string is just A. The size is 1 because there's only one terminal letter. And the out positions of that should be 1 as well. That's my suitcase, and then this should be suitcase. Okay, and what am I doing wrong? Tree errors, aka is not convertible tree errors, comma. Tuples are a different number of elements. Okay, it's just behind the times. I hope. Do I have other? Okay, I'm gonna take this one out. I'm gonna put it here, like so. Circle equals requires. Okay. Let me break them out then. A is suitcase dot original. One is suitcase dot size. Okay. Oh man, come on. um. This is somewhat arbitrary here. Excuse me. I'm gonna get a drink real quick while that runs. Oh, not everything succeeded. Okay, let's go track it down. Ah, okay. Well, I don't really think this test is active yet. I mean, we put some dummy stuff in. This structure is more or less okay, but that's not what we're going to look like. So I'm going to make this an X test. Okay. All right. Now this one, yes, we expect this to fail because we haven't done anything in our analyze yet. All right. So the suitcase, it needs to be um, the input. Well, we almost really need this string. I don't think array is that compatible? No. I don't know if I can. Is that compatible? Okay. The size is position count. And we always kept it increment after you do it, so it's always current. And the out positions is tree equal parse. Tree dot out. Okay. Expression resolves to an unused variable. I think I have to say return, that's all. Okay, and I think this should pass. Okay, cool. So I think our compiler, it's a little better than it was. Okay, so we combine our lexical analysis and our parser, maybe good, maybe bad, but analyze produces a parse tree, and let's rename this to tree. I think parse the verb and parse the noun just don't mix very well. Okay, so tree suitcase parse errors. We blend in any errors. Not interesting, I guess. Intermediate code. We generate intermediate code given the tree in the suitcase, and we produce something. We got to get that right. And then once you have intermediate code, which is mostly our out function, but we'll get the rest, then you generate real code, and you return the errors in the code, and the visual runtime takes care of that. Okay. Okay. So right now, I think our intermediate code is inadequate. All right. So intermediate code, it needs the original expression. This code of string thing is not relevant. It was helpful for us to get the A out there so we could at least see something running, but not meaningful. Okay, and so we're gonna take this out. Somebody's relying on that later in generate, and we'll deal with them. But intermediate code, this is back to what does our algorithm need? It needs the count, it needs the out, and it needs the triggers. Okay. So the original expression, well, it needs a count of integers. It needs the well, it needs the original expression. Yes, that's true. Because we display it. We need the count. We need, we'll skip, but we need the out. Out positions of set of int. And then the triggers. All right. That's what we want. This right now we don't have. Are you going to volunteer? No. Okay. Let's see. So I'll just say count -1 out positions set event and trigger set a trigger row. Okay, so our generate intermediate code is garbage basically. Okay, so let's do that. All right, and we'll run tests. I think some of these tests on the generate intermediate or the compiler one may blow up. No? Okay. Everybody's happy enough. All right. So intermediate code, it's really pretty minimal. We did the trigger calculations. I don't know. That's I don't think my abstraction of intermediate code is turning out to be too helpful. Let's see. Function. We're gonna say generate intermediate code from tree and suitcase. Okay. And so I make a compiler. We'll let tree and suitcase, and we'll ignore any errors, equals parser of, I think we'll keep it simple, dot analyze. Okay, so that's the stuff going in. We want to say let intermediate code equal generate intermediate code, compiler dot generate intermediate code from the tree I don't know if those are redundant. Okay, and then we'll assert some things. We expect intermediate code original expression to be right. Which is A, is intermediate code dot original. We expect count to be 1. We expect our out positions to be the set of 1. Out positions. And we expect our triggers. Oops. Well, I mean, really, I don't know if I'm being lazy here, but let's say trigger, the trees trigger at positions 0. Set. Tree trigger position 0 should be the same as intermediate code dot triggers. Okay. This function should fail because this code doesn't do that stuff. All right, original expression is fine, count is wrong, 1, and that. Okay, so original expression, this is suitcase dot size. This out positions is tree dot out. And triggers is tree dot trigger with positions set of 0. Okay, should pass. Yeah, so intermediate code, you know, it probably could just be suitcase, could probably be that. It's not really intermediate code, but we'll leave that for refactoring. Okay, so I just heard my cuckoo say it was 2:30, so we got about 25 minutes left to try and get the code generation. So I'm hoping we can finish this. I have a lot of cleanup I have in mind, and I have some ideas I want to explore, but let's see what happens. So this generate code input, I think what we're going to do, I'll say code generation. All right, my compiler, what do you put in? Compiler, we say compile. Okay, well, we'll ignore errors and just get code. Is compiler dot compile, and we'll just start simple. Okay. Right. So, basically we're saying do the whole thing and let's make sure it equals something we expect. Okay. So, this is code. And this thing is code. So in here, we're going to put the code we expect to get. And we know we need this line because that's just boilerplate. And we know we need something like this. And this should be just A in our case, coming right from there. I'll accept a blank line, that's fine. And I need an accepts function. And this. Okay, so this is not fully filled out, but I'm just going to run it for now just to get a baseline, I guess you'd say. All right, the code in here, 206, that's the code we need to deal with. Okay, so matcher expression A accepts. The current compiler spits out this. We don't want that. Okay. The code we want, yikes. We're trying to do this algorithm and we hope it generates this code. Okay, so In here, main, I mean, basically, I want to initialize state. Um, I'm going to say state 2 just to be different, I guess, but state and state 2, and actually, you don't even really need to initialize it because it doesn't get used till the first one. But then there's a for loop, and then at the end, something to figure out if you passed. Um, woof. I don't know. This algorithmic, it's like we're just implementing this algorithm. So why are we fussing with it? I don't know. All right, but I'm gonna say that there is a variable state, and its type is bool, array of booleans, and then really he equals well, he's going to be something like false false, actually true false. Okay. I guess we got to look at our algorithm to make sense of it, but it's got position 0 is false, and then position 1, in this case 6, because he's got 1, 2, 3, 4, 5 plus 0 positions. He's got the count of 5 plus 1 for the initial 0 position. So in our case, with just A, we have this and this. So true and false. He's got ints. I'm going to use booleans. Yeah, that's just a difference. and then we need the character loop. Okay, whoops. We got var state 2 of boolean, and then for character in input, I think that's all we have to say. Do some stuff, and then at the end, we're going to return something. Okay, and in our case, you match A, you started in 0, you matched A, you should be in position 1. So we want to say state sub 1 is true, return true. Okay, and in the loop, we initialize the two state 2 values and then copy state picks up state 2. And honestly, that means this can go inside. Well, I'm not sure if I'm compressing things too much, but this should be, it should start false, false. And it says state 2 sub 0 equals character equals and this or that or that. So if you, well, what's our set? It is the same as character equals A and state sub. Oh, state 0 equals 1. Character state 1 is going to equal that. Okay. Meaning true. Do I have the case right on these? No. Okay. And I don't know. This is it's hard to know how much to do on these algorithms like this, but we're always able to be in state 2 sub 0, state 2 sub 1 equals character equals A and state sub 0 is true. And then we want to say state equals state 2. Okay. So the claim is if the code is this, it matches things right. And I think there was something about that state 2. If it's 1, you start anywhere. If it's 0, you start at the front. So let's make it 0. False. Okay. Now, I should be able to take this and paste it in here. If that compiles, all right. Nope. Type. Oh, these are brackets, right? Okay, let's put them back here. This is weird to me, but okay. I think this can be initialized better. But again, I will copy this, paste it in here, and run this application. All right, and if I type X and check that, no. Type A, check that. Ends with A, no. Starts with A, no. Okay, so it's doing what we thought it should. All right. And I'll run this again. Okay, let's see. Can you explain what's going on? So the code we're trying to do is we're trying to take in a regular expression. We're trying to generate code. So this is the code in purple is the code we expect to generate, and we don't have the algorithm quite there. We got all the intermediate data we need to generate this. We haven't done that yet. But once it's generated, we should be able to put in any regular expression, generate some Swift code that will match it in this sort of template that we have going. Okay, and so we're gonna make that algorithm go. I don't know if the time may be a little short, but I mean, this is sort of the dummy way right now. I make it pass just by forcing it to be true, to be what it is. Should pass, right, but it doesn't handle anything useful, or it only handles this. Okay, so the generate, let's go back to that algorithm. So you can kind of see what they're talking here. So we need these bits of stuff. We're going to allocate a state vector, initialize it with slot 0 is 1, then 0 for all the rest, used up to m. Okay, so let's try and make that step go in. Okay, so instead of code, I'm going to call this prefix, and down here I'm going to let code equal prefix for now. Okay, so the prefix, well, maybe I'll make it a template. Well, it is a prefix, but I will make it a template in effect. I'm going to say this is original expression. Okay, and yeah, I'm going to call this template. We'll get there eventually. But I'm saying original expression is here, okay? And then I got to have a state declaration. That's this. Okay, so let the state declaration equal this. I guess I don't need leading spaces. I can leave them here. A state declaration, this character and input, that's fine. State 2 declaration is this. Declaration. Okay. State 2 declaration goes here. Okay, body, and then this is okay, I haven't dealt with the middle yet. we'll get that. I guess we'll call that body. Stop. Okay, so this needs percents. So I'm just defining this little template language. Let's make this copy update state. Okay. Do I have everything now? State declaration, character and input, body, update state. Okay. So I'm going to say template dot dot is it replace? I have a string with replacement string. Okay, yeah, let's do that. Okay, so we'll replace original expression with okay, replace that with original expression. and dot replacing. I'm just going to work through them. State declaration. Occurrences of state 2 declaration. Body, and then update state. With update state. Excuse me. And finally, return value with return value. Okay, so I've basically said I had my original text. I've pulled out all these chunks. I said replace them, and then I'll return that as the code. There's probably better structures to use for this, but I think this will get us moving forward. And this should still pass. I mean, all I've done is templatize it. I might have some spacing issues or something, but and it's gonna be kind of hard to see them, isn't it? I still have state 2 declaration. Did I spell it wrong? State 2 declaration. State 2 declaration. Okay, and then this is 4 characters in. This looks like it should be 6. Okay, we'll try again. Okay. Public class manager var expression equals A looks good. Func accepts. Input looks good. Var state equals bool true false. Return input var state 2 sub 0 equals false. Oh yeah, body's got to be over here. Okay, this is progress. All right, that bell is. I've got about 3 minutes left. Let's try doing it from the intermediate code. I'm going to call it int code instead of input. Okay, so where I can do it with the intermediate code, let's do that. So this should be intermediate code dot original expression. That's fine. The state, update state, I think that's okay the way it is. This one depends on the count and the body, and the return value depends on the things. Okay, I guess, I'm not going to finish this in 2 minutes. We'll see if we're keeping things the same though. I mean, I want to at least do that. Yeah, I don't need this one anymore. Okay, so we will unfortunately leave it off till tomorrow. So tomorrow, 1 to 3 p.m., I'll repeat. I'll do this session again. I mean, we'll continue on, but we're very close right now. We're just to the point on the algorithm. Okay. We've done step 1. I've sort of hard coded this dimensional vector, but you can see that we could iterate through the count of 1, 1 m plus 1. So m is the size. I don't know why they're calling it poundy here and m here, but Yeah, there we go. M is pound E. We could certainly generate the booleans here. This one's a little more complicated. This is running through well, this one's not bad. This is that first letter. We only want to match on the first letter, so we'll just make that hard coded to false. And then we have to run through the trigger set and generate these things. And then we'll do something at the end to figure out if you're in the legit ending states. Okay? So we'll pick up there. Thank you, as always, for joining me. I hope you can come back next time or in the future. Like I said, I normally do this Twitch 3 times a week, Tuesday and Thursday, 1 to 3 p.m., Wednesday, 9 to 11:30 a.m., all Eastern time. So thank you and have a good evening.